Hi, in this video, we're going to have a look at some basic factorizing techniques using examples from the textbook. So I'm working from exercise 3B here, and the first one I'm going to have a look at is 1E, which is 18x plus 12. So we look at the numbers first, 18 and 12, and we sort out what the highest common factor of 18 and 12 is. And the highest common factor of 18 and 12, you should know, is 6. And so we put the 6 outside the brackets, and then we open the bracket like so, and then we work out the rest of it. And I tend to work backwards. So I go 6 times what will give me 18, and the answer is 6 3s are 18. And then I write my variable in, and then 6 times what will give me 12, 6 times 2. So I write positive or plus 2. So that's that factorized. 6 outside of 3x plus 2 is how I would say that. In example 2, we have 8ax plus 32xy. This is 3B, 2b. So again, same sort of format. I look at the numbers first and take out a common factor. So the common factor of 8 and 32 is 8 because 8 4s are 32. So I take out a common factor of 8. I then I have a look at the variable a, and a is not present here, so it's not a common factor to both of these. Then I have x, and x is a common factor to both of those. So I can pull out the x. And because I'm looking for common factors, I don't need to consider anything else. Once I get to the end of one term, I don't have to look at the other term. Open the bracket and then see what's left over. So I tend to, again, you can do it a little bit faster with practice, but you're going 8 times what equals 8. The answer is 1, which I don't have to write in unless it's the only thing left to write. But I do have an a here that's not missing. So I've got x times 1 equals x, but the a is missing. So I can put the a in, plus 8 times what equals 32. 8 4s are 32. And then the x is already present. And then we've got a y. So I'll put the y in as well. So that is now fully factorized. Now, the third example looks initially like there's no common factor here. I mean, we've got x's here and here and here, but there's no x here. So initially it looks like it cannot be factorized. And remember, factorized means put into product form, two things multiplied together. But we're going to use a little technique called grouping. And the factor we're going to take out is an expression instead of just a single term. I'll show you what I mean by looking at example 3. If we have a look at these first two terms here, there is a common factor of x. So I'm going to take out a common factor of x just on the first two terms, and x squared is the common factor. So I'm going to take out a common factor of x squared, and then I'm going to see what's left inside. X squared times what equals x cubed? X squared times x equals x cubed. X squared times what equals 5x squared? X squared, 5 times x squared equals 5x squared. So I've got a common factor of x squared, and that leaves me with an expression x plus 5. Now, over to the side here, I've also got an x plus 5, which I'm just going to put brackets around, even though I don't normally do it, just to spell out that that's a common factor as well. Now, it's not our normal common factor, because you'd normally go a single number or term for a common factor, but it is a common factor. X plus 5 is just a number. I've got x squared, lots of x plus 5 here, and I've got how many lots of x plus 5 here? Pause the video and think about it for a second. Okay, assuming you did do that pause and think and whatever else, I'm going to take out a common factor of x plus 5, like so. Well, what does that leave me with? X plus 5, think of it as a whole unit. X plus 5 times what will give me this expression here? X plus 5 times x squared. X plus 5 times what will give me x plus 5? Now the answer to that is 1. And so I'm going to put x squared plus 1 here, like so. And so that's the solution to 3B4A. X plus 5 times x squared plus 1. It's more complicated, but it is factorized because we've gone from the addition of a bunch of things to a product of two expressions. And so we would consider that factorized. And I'll leave that video, or this video, here.